So, last unit, we did congruent stuff. The very first thing we learned in our last unit was what congruent meant. For Candy, I need someone to tell me what congruent means. We actually wrote it down in our notes.
Two things are equal.
No. Yes.
Two things are similar.
No. Yes? Okay, you already tried.
They equal the same.
No.
Same size and shape.
Same size, same shape. Okay, that's what congruent was. And remember the equal made us think same size, and the squiggle meant same shape. They were both. In this unit, we're going to focus on the squiggle. The squiggle. That's the symbol for what we call similarity. Similarity just means same shape. Okay? And it takes two things to happen in order to have the same shape. Okay? The first thing that makes stuff similar is if their corresponding angles are congruent. That's supposed to be an R. So if all your angles are congruent, you're partway to being similar. The other thing that has to happen has to do with your corresponding sides. Now, if your corresponding sides were congruent and your corresponding angles were congruent, you'd have congruent triangles. So our corresponding sides aren't going to be congruent. Our corresponding sides are proportional. That means whenever I make a ratio comparing one part of a triangle to its corresponding part in the other triangle, they will make the same ratio. Okay? And so when we use the symbol for similarity, we can write a similarity statement. Similarity statement. Remember doing congruent statements? Where you said one triangle was congruent to another triangle?
Yes, sir.
We do the same thing for similar. And we just use our little similar squiggle here. What was the most important part about writing the names when you did congruent triangle statements? Yeah.
Making sure they all matched up.
They all had to match up with their corresponding things, right? So whatever you have to do, you have to match the corresponding parts in the names. Okay? That's still true for similar triangles. You have to match up the corresponding stuff. And I am going to be attempting to bamboozle you all over the place. So make sure you read carefully what I say is similar so you don't match up the wrong junk with the wrong junk. Okay? So for example, here I tell you that triangle RST is similar to triangle XYZ. So I know that all the corresponding angles are congruent. So what angle is going to be congruent to angle R? How did you know? They were in the same position in the name, so they must be corresponding in the picture. Okay? So what corresponds with S?
Y.
Why not? And what corresponds with T?
Z.
And Z. Yay. It's very exciting, isn't it? Oh, you just listed the pairs of congruent angles for me. You just said angle R was congruent to angle X, and then you said angle S is congruent to angle Y, and then you said angle T is congruent to angle Z. Wow, that was rough. Okay? Now, if these are really similar, then the corresponding pairs of sides should all make the same ratio. So go back here. What side corresponds to RT?
XD.
What's that one? How do I know XZ corresponds to it?
Because in the same spot.
See how R and T are at the front and back here? So X and Z should be in the front and back there. So they're corresponding. So I could make a ratio of RT to XZ. Okay. See how I did the one on the left over the one on the right? If I want to compare it to another set of corresponding sides, will I want the big one on top or the small one on top?
Big.
I want the big one because I started with this one here and went to the smaller guy here. So I've got to start with the big guy here and go to the small guy here. So TS, I'm going to put in a ratio with ZY. And since they're similar, what should be true about these two ratios? They're supposed to equal each other. When you get into a proof, oh wait, we're going to be getting into proofs on the homework. If you see sets of corresponding sides making a nice true proportion, that's going to imply that you have similar triangles. Oh, but it's got to be all three sets, doesn't it? So what would be the third set that I could say is the same ratio?
RS.
RS could go with XY. So there you go. So this right here, ignore what it tells you. If you see that you have sets of sides being in a proportion together, that's a statement of proportionality. That will tell you if all three of them work, triangles are similar. Okay? Let's check that they really are. What are my numbers for RS and XY? RS is 20. What's XY?
12.
To 12. Okay, what's RT? 25. And what's XZ? 15? And then what's TS?
30.
Thank you. And what's ZY?
18.
18. Do all of them really equal each other?
Yeah.
They don't look like they equal each other.
They got to be simple.
Oh, you have two ways of checking though. They either all simplify, remember they all simplify to the same ratio. That's one way to check. What's the other way to check?
They add the other.
Cross
Multiply.
products. Remember, the cross products should be equal. You should be able to cross multiply and get equal crap. Okay? Well, what does 20 over 12 simplify down to? They both divide by 4.
5/3.
5/3. What's 25 over 15 simplify to?
5/3.
Oh, wow. And 30 over 18?
5/3.
Oh my gosh, they all simplify to the same thing. Guess what that's called? When they all simplify to the same thing, that thing that they simplify down to is called your scale. Okay? Shh. But when we do a scale factor, okay, it's a simplified ratio of corresponding sides. Okay? And we like to always do it in a certain order. Okay? We always compare the newest shape to the oldest shape. Okay? And so we're always going to put the new shape on top of the old shape. Okay? How do you know which one's new and how do you know which one's old?
One that goes first.
Okay. Well, the first person to be born, are they the newest person or going to be the oldest person?
Oldest.
The oldest. So the one you say first, oh look, ZYXW here, he corresponding first. That's the old fella. Oh, it's not a triangle. That's a quadrilateral. Very good. And so this guy that's done second is the noob.
1, 2, 3, 4.
What does DD mean?
Where? Oh, that's old. I just put the O a little close to the L. Old fella. O-L-D. Yes?
But for the first one, wouldn't RST be old? And the new?
Well, up here, I wasn't doing the scale factor. I was doing a scale, a comparison. But when we do what is specifically called a scale factor, it's always new to old. Okay? Alrighty? So, let's check that our corresponding angles have the same measure. What should correspond to Z? It should be F. Are they congruent?
Yes.
Angle Z is congruent to angle F? Okay. Is angle Y congruent to angle G?
Yes.
Okay. And then you check, is X congruent to H? So angle X is congruent to angle H. Whew, this is taking forever. Is angle W really congruent to angle J?
Yes.
Are you sure? How did you tell?
Because,
Right angles apply.
Oh, because right angles imply congruent angles. So that one wasn't marked congruent, but you figured it out real fast. Okay. So I have all the angles congruent. What else has to be true to make shapes similar?
Sides have to be.
Okay. And here, let's do it with scale factor. That means let's do it in a certain order. Scale factor says to do it in what order? New to old. Okay? So what's one of my new sides?
F.
F is not a side.
FJ.
FJ. So if I do FJ, that's 16, what's the old one that corresponds to it?
ZW.
ZW. So it's going to go with 20. That's my new to my old. And what scale factor does that make? They both divide by 4.
They do,
4 fifths. Now I have to check all of the other ones. So what's another set of sides I have to check now?
20 over 25.
Oh, and how do you know to put 20 over 25?
FG.
Because I have to do new to old. So I'm going to do 20 over 25. Does that simplify down to 4 fifths?
Yes.
Awesome. So it has the same scale factor. What if I use these right-hand sides? Which should go on top, 12 or 15?
12.
12. Does 12 over 15 simplify down to 4 fifths?
Yes.
Okay. What about the 24 and the 30? And you think, oh, they both divide by 6? And so 24 divided by 6 is 4, 30 divided, yep, they all work. So they all have the same scale factor. Yee! Could I have set up those proportions flipped over?
Yes.
No.
Well, yes, but would it have been the scale factor anymore?
No.
No, it just would have been a ratio that compares them. So the scale factor is just a special name for a special way of comparing them. But there's other ways to do it too. This is just the one that gets this name.
Wait, I don't know what triangle's gonna do in the old. This is the one that's on the right side.
Okay, so to help us figure that out, we read in the English language left to right and top to bottom. So which one here is the one you get to first, reading left to right? This one on the left. So this would be the older one, because it'll have been around longer. And this will have been the newer one. Okay?
But so is the one on the right always been...
Unless I say otherwise. Okay? So if I say you've got an old geezer and a young guy, but I put the old guy on the right, but you know he's the old guy, you know to put new over old. Okay? All right. Shh. So since we have proven that these polygons are similar, because we've proven all the angles are congruent, and we've proven all the sides have the same scale factor, can you now write a similarity statement? Okay. What should we start it with?
I don't know.
Well, it's just saying this shape is similar to that shape. So what do you want to say the name of the first shape is? They kind of give you an idea.
X, Y, Z.
So could I call it XYZW? Could I call it YZWX?
Yeah.
Could I call it WZYX?
Yeah.
Yeah. Doesn't matter how you name the first one. I'm going to use what they used here. So I'm going to say ZYXW. But now I'm locked in. Now that I've said ZYXW, what does the other one have to be?
FGH.
It has to be FGHI.
I thought it was J.
Oh, did I do it wrong? Oh, it's a J? Oh, man. Miss Cerna, see, you caught my mistake. That's a J. See? This is what I need you guys around for.
Do you need to put the triangle symbol?
Are these triangles?
Oh, right. It's a polygon.
It's some kind of polygon, and once you start getting bigger than 3, we just say it's got 4 letters, it must be a quadrilateral.
Okay.
Okay? Good question, though. Okay. Oh, he's alive. I can see him moving.
He's not moving. I was moving into that beat.
It is being a very mundane Monday today. It is being the Mondayest of Mondays.
Mistake so I can get candy.
Well, I did. He just beat you to it. Gotta be fast.
Yeah.
Come on. Okay, so here, for this next example, I am telling you that the triangles are similar. Absolutely 100% certain the triangles are similar. I'm telling you to find x using the scale factor. What does that require you to do first? Well, I mean, yeah, think. You have to find the scale factor first. So there are lots of ways to solve this, but I'm telling you a specific way to solve it. So if you did it a different way, would you get full credit? No. So in order to do scale factor, you're going to have to set up a ratio of sides that involves what on top? New on top of old. Okay. So what's a ratio of sides you can make so we can find our scale factor?
You can do 20 over.
I could do 16 to 12. Oh, that's supposed to be 16. I said a 16 and I wrote a 12. Mrs. Cerna. What could be another one I set up that should have the exact same scale factor? Yes? Well, I could do 20 to x, but will that tell me the scale factor?
12 over 9.
No. But 12 over 9 could also tell me the scale factor. Either one should give you the same scale factor, which it turns out to be what is my scale factor. 4/3 is my scale factor. Now that I have the scale factor, it says use the scale factor to find x. So how am I going to use my 4/3 to find x?
Well, you compare it with 20 over x.
Well, but okay, so I need to set it up. Where should the x go? On top or on bottom? How do you know?
Because it's old.
It's an old piece, and remember this is new over old. So x is part of the old guy, and its corresponding part is the 20. And now you get to cross product like crazy and check. Okay, so Dominic, what's the 4 times the x going to give me?
4x.
And what's the 3 times the 20 going to give me? And then what should I do?
Divide.
Divide. And so x is going to come out to equal what? Something like 15? And oh look, it gets to be naked because I didn't give you any numbers. So indecent. No, you pull that back down. We don't want to see your gross wounds.
They're not going to play.
But wounds,
I know, yeah. Why are you worried, bro?
All right. Questions so far?
No.
Cool. Halfway there. Y'all are doing good. But just don't use that word. Golly. What are you trying to do?
Colin wrote easy on his warm-up.
I didn't write that. I was in the bathroom and they wrote it on
It was
my
quoted by.
Oh, you were framed?
It was quoted.
He did it.
Okay. Shh. So. I'll wait. So the cool thing about scale factor. Oh wait, scale factor is set up how always?
New to old.
It's always new to old, right?
Yep.
Well, when you do perimeter of similar shapes, the scale factor of the perimeter will always equal the scale factor of the individual sides. That's supposed to be a cursive S and I can't write. So whatever scale factor you came up comparing the two sets of sides is going to be the same scale factor you get if you compare their perimeters. Okay? Which you can use to your advantage. Behold, an Olympic pool is rectangular. I'm assuming, I don't know, I don't swim like that. With a length of 50 and a width of 25. Is that really, does anybody swim? Do you know if that's really how big Olympic pools are?
Yeah, they are.
They really are?
They're 50 meters.
50 meters. Okay, shh. So we've got this here Olympic pool. Well, them's big pools. Are most backyard pools that big?
No.
No. So you want to build one that's the same shape but smaller. You want it to, only be 40 meters. That's still a honking big pool, but you know, it's not as big as the Olympic one. Okay? So, behold, find the scale factor of the Olympic to the new. Which one goes on top? New. And so the Olympic is the old. Okay, so what's your scale factor? Set it up. What's the only set of numbers I can use here?
40
to the 50. That's the only thing I can use. Why can't I do 50 to 25?
Same thing.
They're on the same shape. And a scale factor is comparing your new shape to your old shape. And I didn't ask you to tell me how did the two sides of the Olympic pool compare. I asked you to tell me the scale factor with the new and the old guy. So make sure you pay attention to that. Because yeah, there's more than one way to find different crap, but I'm asking you to find certain stuff. Okay? So now, find the perimeter of the Olympic pool. Okay? Find the perimeter of that Olympic guy. How do you do it?
It's 2 lengths times 2 widths.
2 lengths plus 2 widths. So 2 of the 50s and 2 of the 25s? So what is the perimeter of my Olympic pool?
150.
Thank you for not leaving it naked, whoever I heard say meters. It's probably Sebastian, right? Oh, it was you. Are you sure?
Yeah.
Okay.
Yes.
He's so surprised.
No, I'm so surprised that you knew it was you and not him. Okay. Yeah. So what's the perimeter of my new pool then?
80 meters.
Do I know?
I don't.
No, but you can use the scale factor to find it.
Other side's 20.
So what was the scale factor of my 2 pools? 4/5. Remember the scale I said 4 and I wrote a 5. See, I did it again. 4/5. Because remember, scale factor is your simplified ratio. So here's the scale factor of the sides. Well, what should be my scale factor of the perimeters?
X over 25.
The scale factor should be the same thing. So my scale of my perimeters should also be 4 to 5. So do I know my new perimeter? Nope. Do I know my old perimeter? Yes. it was 150. So I can use the scale factor I found from just doing the sides to set up finding my perimeters, because they have the same scale factor. It's magical. All right, what's 5 times P? 4 times 150, 15, 30, 45, 600? Something like that? Then what?
Divided by 5.
Divide? And P equals something like what, 120
Meters.
meters?
I think it's 120 meters.
Hey guys, could you, without finding the perimeter here, have figured out how big that side was?
Yes.
And could you have used that to find your new perimeter?
Yes.
Yes. But this problem was specifically asking you to use the scale factors. And so that's why we did it that way. But if I don't tell you which way to do it, do I care?
Nope.
Oh. So there is the scale factor way of solving stuff, but there's other ways, and just pay attention to which way I'm asking for, and everybody will be fine, and nobody will have to suffer needlessly. But of course you get to suffer no matter what, because it's geometry. Right?
Yeah.
Of course. Now, we get to have some implied statements. But, out of the kindness, goodness, and generosity of my kind, good, and very generous heart,
Yeah. We don't have to study.
no implied statement quiz this unit.
Oh.
We'll do one next unit after you've forgotten everything.
Okay.
Yay!
Flipping go.
Okay?
You just said again?
LFG.
Nope.
Hey. Watch your mouth.
Now,
You got it.
so, to prove triangles congruent, hi, remember congruency?
Nice posh.
Did you have to prove all 3 sides congruent to all 3 sides and all 3 angles congruent to all 3 angles to be able to say the triangles were congruent?
No.
No, we had shortcuts. What were my 5 shortcuts?
Side angle side.
Side, angle, side,
Side side side.
Angle, side.
angle, angle, side,
ASA.
angle, side, angle,
Side side side.
side, side, side,
HLR.
and HLR. They were shortcuts. Okay? We have the same thing for similarity. Because remember, on the front here, we proved all the ratios equal, and we proved all the angles congruent. But you don't have to. So remember angle, angle, angle? Ah! And that one wasn't allowed? I'm so sorry, those of you on the video. I do that a lot.
You need to watch that one too.
You gotta watch that one. Angle, angle, angle did not tell you congruent.
But
It could tell you similarity, but it's more than you need. You actually only need angle, angle to prove similarity.
For a triangle or for all? For a triangle?
For a triangle.
Oh, yeah.
Okay? And look why. If I have J congruent to X, hi, talking,
Hi.
K congruent to Y, do I know enough to figure out that L is congruent to Z?
Yeah.
Well, do I? Well, no, just in general. If I knew that this was 30, and this was 30, and this was 60, and this was 60, could I prove that the other two were both equal to 90?
Yeah.
How?
Because triangles is one.
Because triangles sum to 180. What if I have this one being 20, and this one being 40, and this one being 20, and this one being 40? Could I figure out what the third one was?
Yes.
Because they add up to 180. So on your Unit 7 test, you have the Josh and Jennifer problem that asks, could you prove it using angle, angle, side, not just side, angle, side?
Was it Jennifer?
You could do it both ways. Yes, whoever said both ways, because they were switched on the different tests. Whoever said that you could do it both ways was the person who was right, because even though it was only marked with this one being with one dot and this one being the open dot, couldn't I then figure out that the last one was congruent to the last one?
You could.
I could. Okay, so instead of needing angle, angle, angle for similarity, you just need to make two angles congruent. So what this says is that if two angles of triangles are congruent, then the triangles are similar. Oh, sorry, if two angles of one triangle are congruent to two angles of another. We don't want someone saying, oh, it's isosceles, it's congruent to the other isosceles, because you don't know that for sure. So it's got to be angles of one triangle congruent to two angles of a different triangle. Okay? And so we get an implied statement for that. If you have two sets of angles congruent, that's called angle, angle. It implies similar triangles. But notice I put the similar squiggle here. This is called our angle, angle similarity. Angle, angle similarity implies similar triangles. That way we don't accidentally mix it up with
Oh.
and do, because that one was a bad one for congruent, wasn't it?
Can you pronounce the difference between a similarity and
Wait,
angle,
what is
angle,
it?
angle?
Angle, angle, angle was bad for congruence. And so we don't use it for similars, so we don't mix it up with the bad thing for congruence. So for similars, it's angle, angle similarity. Shh. So, let's see if I can bamboozle you. Determine if the two triangles are congruent by angle, angle similarity.
They're given.
Similar.
C.
Can I prove they're congruent at all?
Yes. Of course.
No.
No.
Because all of our congruent things require congruent sides. Do I have any congruent sides here? Then I do not have enough to prove congruent. But maybe they're similar. For similar, I would need angle, angle to match up. Do I have a set of congruent angles?
Yes.
Yes. These right angles are congruent to each other. Oh, but 26 doesn't equal 64.
They're not on shucks. So it don't matter.
But if only I knew how to check how big the third angle of that triangle was.
That would be pretty hard.
Well, isn't a right angle always equal to 90 degrees?
Yes.
Could I now calculate how big angle E is? Guess how big it is.
64.
Turns out to be 64 degrees. Oh, wait! So if 90 and 64 and 26 go together, then 90 and 64 and 26.
Oh my gosh.
So do I have at least two sets of congruent angles?
Yes.
Okay, so these are congruent by angle, angle similarity?
Yep.
Great! Write the similarity statement. Triangle something is similar to triangle something else. Just write the statement.
We'll do that.
Please be bamboozled. Please be bamboozled.
I'm very much
I am
bamboozled.
very bad.
This is torture.
Okay, so Sean, name the first triangle for me. Name it whatever you want.
CDE.
Oh, that's so boring, but okay, C, D, E.
Why is there a better one?
No, this is just alphabetical. Everybody does C, D, E.
Gosh, you're a loser. Wait, that's rude.
Yeah, we would never call people names, would we? Oh, shh! So since we put it in this order, now the other one has to be in a certain order. So Cole, what would have to be the one that matches up with C? How come? Why would C have to go with K?
is about 26 degrees.
They are both the 26-degree angle, so K is going to have to go first. Then what goes with D? G, because they're both the right angles, and then H is left over. Okay. They are similar. Do I know the scale factor for the sides? No. Can I calculate it on these ones? No, I don't have any of the sides, so I don't know what the scale factor is, but I know it exists. It's something. I just don't know it yet. Okay, cool. Guess what we can also do to prove similarity?
Side.
Yes, but this is side, side, side similarity. Because, no, listen.
Guys, she wants us to be quiet.
If you just have side, 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 you're talking about congruent sides. Side, side, side similarity is different. Side, side, side similarity says if corresponding side lengths of two triangles are proportional, not congruent, then they are similar. That's a triangle. Okay? So if I have triangle ABC, and then I have triangle DEF, okay, then the proportions have to match up. So what would I match up with AB? What side do you think matches up with AB? DE. So let's say those are the corresponding sides, and I put AB over DE. Then, now that they are a ratio, then this set of corresponding sides better be proportional. So what's going to go there?
D equals
And then BC would have to match up with EF, and the proportion would have to be the same. Are they necessarily the same numbers?
no.
No, this could be 4/5 and this could be 8/10. Okay? And what would have to be my other one?
FD.
DF would go with, oh wait, DF wouldn't go on top, would it?
No.
No. AC would go with DF. Is this set up in scale factor order? No, this is set up old to new. Scale factor is always new to old. But it doesn't matter, because are these all going to be the same ratio? Yes, they just aren't in scale factor ratio. Okay? Question. Are congruent shapes similar?
Yes.
If I have a 3, 4, 5 right triangle, and then I have another 3, 4, 5 right triangle, are those similar by side, side, side similarity? Well, what's a set of corresponding sides?
3 and 3.
3 and 3? So I'd have 3 over 3. What corresponds to my 4?
4.
Are those an equal proportion?
Yes.
Yeah, they both equal what?
1.
1. Does 5/5 go with 5? Does 5 go with 5?
Yes.
Does that have the same ratio?
Yep.
So we get this interesting thing that everything that's congruent is technically similar. But is everything similar congruent?
No.
No. You're going to have fun with that on your first proof in your homework. Okay?
Yeah.
So, I'm going to give you triangle ABC. There it is. Is DEF similar to ABC?
Right.
Check. How do you check? That, well, yeah, always use your brain, but what will your brain be doing?
Math.
I'm gonna be mathing.
So, how do you know which side is being compared to which side?
Corresponding.
So DE is being compared to AB because they're in the same place, right? So they're asking you to compare DE with AB.
Okay.
So that'd be what, 6 to 8? Then what does BC correspond to? It should be EF. So that's going to be, which one am I doing? 9 is going with 12. And does AC go with DF? AC and DF. So 12 is going with 16. Am I allowed to put the right-hand one on top of the left-hand one? As long as you do the same thing every time. So here I did the right-hand side guy over the left triangle. So then I did right over left. And then I did right over left. Could I do left over right? Yes, the ratios should be the same when you flip them. The proportions are the same when you flip them over. My question is, are all of these equal?
Yes.
What's the ratio that they're all equal to?
3/4.
Is it 3/4 or 2/3?
3/4.
It is 3/4? Okay. So is this one similar to ABC?
Yes.
Okay, check the other one.
No.
It's not! Which one didn't work?
The J, or the,
Yeah, what's AB supposed to be matched up with in this triangle? AB is being lined up with GH. So AB, 8, is being lined up with 8. And so then what's BC supposed to be lined with here?
Probably.
HJ. HJ is 10. Does that line up with BC 12? Are those equal?
No.
No. So are these similar?
No.
No. Not similar. Bad.
Jeez.
Not similar.
It looks like it's true.
Do I need to even check the last set of sides now? No. Because even one set not working blows your side similarity. But wait. There's more. No, not side angle. That one's still bad.
Angle side.
We can't do angle side. But I can do side angle side similarity. Shh. You want to know this one for your proof. Okay. So if two sets of corresponding sides are proportional, I can't spell, and the included angle is congruent, then the triangles are similar. Okay. So looking at these triangles, I need the proportions set up. What proportion could I set up? Remember, you got to compare similar parts to corresponding parts to corresponding.
15 over 18.
So you think 15 should match up with 18, and then what would that match up on the other sides?
30 over 9.
It'd be 30 over 9. Are those proportional? Do they make an equal ratio?
Let's check.
No.
What does 15 18 simplify to?
5, 6.
They both divide by 3.
It's gonna be like
5, 6. Oh, these both divide by 3. That's 10/3. Are they proportional?
No.
Guess why they're not proportional? I didn't set up the corresponding sides. Try setting up the 18 with the 30.
Oh my goodness.
And then try setting up the 9 with the 15. So if 18 goes with 30, let's try putting the 9 with the 15.
That'll be 9 too.
Is that a proportion? Yes, it is. So now I have two sets of sides being proportional. Am I able to do side angle side with these two sides?
Not just, you need an angle.
I need an angle that's included between them.
You have,
Can I do that?
Yes.
Okay, so Abraham, what rule would let me say that these two angles are congruent? Why are they congruent? They're vertical angles.
how convenient.
And vertical angles are always congruent. So now I have a set of vertical angles being congruent, and I have the sides on either side of it being proportional. So could I do side angle side similarity here? I could. And then, so what would be my similarity statement then? Be careful. Okay, so Olivia, what do you want to call a left-hand triangle? We'll start with that.
ABC.
You're not Olivia, unless you changed something about yourself.
I think 5.
CAB. See, now we're having some fun.
Yeah.
So if I set up triangle CAB, what letters do I have to write in order for it to be similar?
CD.
She did C, going out to A, and then down to B. CDE? But why not CED?
That's not right.
Not how it is.
Because I got to do the corresponding stuff. And to go from C to A to B, I go along this side that's pink. So I have to go along the side that's pink. So CD to E. Okay? You got to match up your corresponding stuff. Okay. So now, you've got some homework. Okay?